So this is our today agenda, and first I will introduce the LTE overview, have a LTE overview and have a channel in LTE and have random access procedure and scheduling. And this is our outline. First we will introduce, we will have a LTE overview, and then have a channel in LTE and have a cell search procedure and system information. And after that we have a random access procedure. And we also have uplink scheduling and downlink scheduling. And the end, we have an overview for porting OI UE. So the first is LTE overview. So what is LTE? LTE, the full name is long-term evolution. So LTE is a wireless data communication technology standard. And we always talk, sometimes we will say it is 4G. But it exactly is 3.9. The 4G we call is LTE Advanced. And this is the correct characteristic. And they have a high data rate. Peak down speed up to the 300 megabits per second. And this is for downlink, and uplink will have 75 megabits per second and have a low network latency. And small IP packet can have less than 5 milliseconds delay under optimal conditions. And also we can save the electronic. And downlink we use OFDMA, and upload we use SCFDMA, and we also have we can support MBSFN. What is an MBSFN? It means multicast broadcast signal frequency network, and we also support frequency diversion duplex and timing diversion duplex. And in Taiwan, we support for FDD part. And our introduction for each layer. For RC, this main purpose to connect the radio resource of control plane and user plane. So for example, you have a configuration for PDCP, RLC, and MAC layers. And in the PDCP, the main function is data transmit in control plane and user plane. And in control plane, they can transmit the command from RRC from here and implement the relative configuration from RRC. And in the user plane, it receives the IP data from upper layer from here and package IP data into a packet and transmit to the RLC. And you also make sure that the order of package from upper layer is correct and not repeat in the reconstruction. So in RLC, the main function is make sure that the packet order and remove the duplicate packet and retransmit. And here we will have TM, AM, and UM model handling. And what is TM? TM means the information doesn't need to be repackaged in the RLC layer. And what is AM? AM is acknowledge mode, and UM is unacknowledged mode. And what is the difference between that? The difference between them is whether it will support ARQ or not. So in acknowledge mode, it can support the ARQ function, and it can need to receive the PDU from RLC and have a egg or neck to the RLC there. And if the RLC doesn't receive egg or NIC, you have to retransmit again. So in MAC layer, the main function of the MAC layer is to perform the RA management for different radio barriers, including including modulation and coding scheme, or resource block and channel control element, and also have a multiplexing and HERQ. And in the final is the physical layer, and the main function is transport channel error detecting, and have a synchronization, and also have a HERQ egg and has some scheduling request. And this is the LTE generic frame structure, and you can see in one frame they will have 10 subframes, and in the one subframe it have 2 slots. And in in one slot we have 6 or 7 OFDM symbols. And what is difference between 6 symbols or 7 symbols? You can see the picture here. The 6 OFDM symbol have a short cycling prefix, and 7 symbol have a okay, I put it wrong. For the 6 symbols we have a long cycling prefix, and 7 have a shortest cycling prefix. And yeah. And what is the why we need the cycling prefix? I think the advantage is to augment the inter ISI. ISI means inter-symbol interface. So, but if you have a long extent CP, you can know you will have a shorter time to transmit the symbol. So they will have a advantage and disadvantage.
Okay, thank you. Before I present about my part, I will introduce myself first. My name is Asif Ali Zabzami. You can call me Ali. I am from Indonesia. And here I will present about channel in LTE. There are several parts of channel in LTE. The first is what? You want to? Okay. The first is I will introduce about what is LTE MAC layer and MAC architecture, and why channel is important and why channel is needed in this part, and the last I will introduce about LTE channel mapping. We are going to the first slide. This is a LTE MAC layer. As you can see here. Wait. Okay. Sorry. Okay, just start. There are two plane, user plane and control plane, as Gina mentioned before. You can see here user plane, and this is a control plane. There is a little bit the difference between the user plane and control plane. The first, I want to tell to you about what is the difference between the user and control plane. User plane using to transmit like voice and data, and control plane is using for transmitting signaling data. Like if you want to connect to the network, you will transmit the control plane. The main concept is like this one, but actually it is very advanced concept. I just explained about the simple one. And there is like a UE part and inode B. Inode B is like a base transceiver station to transmit and to receive data from the UE. And if you transmit your data from the UE to inode B called uplink, and if you receive data from inode B if you are a UE, if you are a UE part UE like a user equipment like a phone, and inode B is like a base station. And if you, friends, if you receive a data from the inode B, means that you get a downlink data. And in the network of LTE, there are like UE and inode B, and actually this part, this is EPC, uh, is in this part actually. So I put a circle here. So it means that in there is a difference like a user plane and control plane. And for the control plane, is directly go to the EPC, and also in user plane, it will directly go to the EPC. But the picture is like a little space here, so I put a circle here. Means that this circle will go to this part. So it's totally same. I just separate the plane like a control plane and user plane. If you want to know the original figure, the figure is like in user plane and control plane. Like there is a connection here and connection here and connection here, and directly go to the EPC. Yes.
I remember the user plane doesn't have RC layer and NAS layer.
Uh,
For data transmission, even do the control.
like you mean in this part there is an
User plane.
in user plane?
Yes.
What?
User plane, I remember doesn't have RC layer and NAS layer.
Yeah.
Yes.
In user plane we also have like this one. Yes.
So I remember the
Oh, you mean that in user plane there is no RRC?
yes. Yes.
Oh,
Because the RC main function is for the
control.
controls bringing information to region.
Oh,
So
okay.
and also NAS doesn't have the user plane.
Maybe I will check later. I think like this part. Okay, okay. I forget. In this part there is like no. And yes, I get from the PDF, and there is one of the channel is not needed in this part. I think in the user plane it not the RRC is not used. Yes. Thank you for the correction. I forget to put it. And after in EPC, so in the last of the presentation, I will tell to you about the tutorial that we already done. In this part, there is like S1 interface. This is a S1 interface because from the inode B, it directly go to the EPC. EPC is like a center. So your database is maybe like in here. And we are going to the next. Okay, this is the.
Can you more slowly because the Skype is online students and
Okay. If you think my explanation is too fast, please interrupt me. Okay. Okay, we are going to the MAC architecture. EU-TRA is evolve UMTS, terrestrial radio access. Yes, as I remember, it's like that, the abbreviation. And defines two MAC entities. The first is one of the UE and one of the EU-TRAN. EU-TRAN and means network. And the MAC layer is composed of, the first is a HARQ entity, the second is multiplexing and demultiplexing entity, and a logical channel prioritization entity, and a control entity. I will tell to you about the first HARQ entity. The HARQ entity is used to transmit transmit and non-acknowledgement. Yes, and acknowledgement if it is needed, and transmit and receive a transport block because the HRQ is in the transport. So this is the upper layer and this is the lower layer. So this part is MAC. Yes. And then multiplexing and demultiplexing, as you know that multiplexing will several channel like several lines will one line will go to the several lines, and for the demultiplexing means that several lines go to the one line. The concept is like this one. So the multiplexing, you can see here there is like some of the several line will go to the first line. It means that demultiplexing. And then the logical channel priority is used to transmit. The first is logical channel will instruct the multiplexing and demultiplexing to transmit. Not to change the service data unit to protocol data unit. So this is the function of the logical channel prioritization. This is in your uplink only, and so on. And why channel is needed in LTE? Actually, there is like several data and several variety of the data. So it is need a channel, and then it is need a different channel in this part. So that's why a channel is needed in LTE. So as you can see in this explanation, in order that data can be transported across the LTE radio interface, because in LTE radio interface there is some different channel, and a variety type of data will be transported across the radio access network. So later you will see there are a lot of channel in uplink parts and in downlink parts. And I think I will only explain in the uplink parts because my partner will explain in the downlink parts. And then in a mapping channel, here you can see there are three parts. The first is physical channel and transport channel and logical channel. And you can see the description of the channel in each part. The first is physical channel. Physical channel is here. So in the layer, the physical channel is the lower layer, the lowest one. So every single word here needed a P, and P, means that physical. So physical random access channel and physical uplink share channel, physical uplink control channel, and so forth. In uplink part, I will only explain in this part because my partner Nikita will explain the downlink parts. So in uplink parts, you can see only a little bit difference, like this part in uplink part only has few channel if we compare with the channel in downlink part. And some of the channel in the uplink part is used in downlink part. Like you can see CCCH mean common control channel, and DCCH mean dedicated control channel, and DTCH mean dedicated traffic channel. So in the logical channel, there are two parts. The first part is control channel, and the second part is traffic channel. And the traffic channel will transmit like a data and a voice, and for the control channel for the signaling. And in the transport channel, yes, the transport channel. This is the channel between. Okay, this part is for the physical, and this is for the MAC layer. So MAC layer is like here. Yes. Okay, and then for the transport channel, the physical layer transport channel offer information transfer to medium access control and higher layer. So the transport channel here and MAC layer here. Okay, I think this is Nikita's part. Thank you.
Hello, my name is Nikita, and I will, as Ali mentioned before, I will quickly go through the function of the downlink channel. And we can see the logical channel. We have the PCCH, blah blah to the MCCH, and here PCCH is for paging, and the BCCH is for MIP and SIP, and the BCCH and the BCCH it will mapping to the BCH, and BCCH and DCCH will mapping to a DL downlink share channel. And in the transport channel, I want to mention about the PCH. PCH is for paging, and the physical channel, I will mention the PDSCH. PDSCH is used for data, and the PDCCH is the most important. You will transmit a DCI, and I will introduce it in the later slide. And the PHICH, you will PHICH, you will transmit the egg and neck, and the PCFICH, you will dedicate the PDCH of the DCI.